Okay, friends, in example 2, you also evaluate Laplace inverse of this one. Yes, in example 1, I have defined some problems, and next one is to evaluate Laplace inverse log 1 plus 1 by s square. And another question is like that. And the solution of first question is let fs is equal to log 1 plus 1 by s square. Then differentiating this, that is f dash s is equal to d by ds log of s square plus s square, and differentiating this you get s square by s square plus 1 minus of 2 by s cube. Yes, clear? Okay. Now therefore this is equal to minus of 2 by s square plus 1. Okay, and now if you factorize this one, yes, then this is again is equal to minus of 2, and this become by partial fraction, this is 1 by s minus s by s square plus 1. Yes, clear it? Okay. This implies that Laplace inverse, on taking both sides, Laplace inverse f dash s, yes, this is equal to, yes, minus 2 Laplace inverse, yes, 1 by s minus s by s square plus 1. Okay, and you know the Laplace of inverse minus 2 Laplace inverse by the linear property also. Yes, you can write down Laplace inverse 1 by s. Yes, and similarly here is minus of Laplace inverse, yes, s by s square plus 1. Yes, you know, and also Laplace inverse 1 by s, yes, which is 1. So the minus 2, and here is 1. Okay, and Laplace inverse s by s square plus 1, this is cos t. So there is 1 minus cos t. Yes, clear? Also Laplace inverse is f dash s, this is again is equal to minus t Laplace inverse fs. From the derivative property, yes, you know, if first time differentiating, then you get minus of t in this one. Yes, therefore this is again is equal to this one. Let us suppose this equation number 1, and similarly by this different derivative property, this can be done as minus of t. Yes, and here is Laplace inverse of, here is in your problem fs is, fs you have suppose here is log of 1 by s square. Yes, you can substituting, here is log of 1 plus 1 by s square. Yes, okay. Let us, this equation number is 2. Now from equation number 1 and 2, yes, here is again this one, here is this one, so you can substitute operating from equation, yes, from 1 and 2, yes, this is equal to t Laplace inverse log 1 plus 1 by s square is equal to 2 times 1 minus cos t. Yes, minus is cancel out, so this becomes this one. That is the according to the question, Laplace inverse of this one, or Laplace inverse log 1 plus 1 by s square, this is equal to, yes, 2 times 1 minus cos t divided by t. Yes. Okay, students, I think you have cleared it. Okay. Similarly, I have defined another question which is Laplace inverse. The second one is Laplace inverse. Second one question is Laplace inverse 1 by s cube s square plus 1. This one. Okay. Here this question you also can solve. Yes, solution of this question. Yes. Actually, since we know that, yes, since Laplace inverse 1 by s square plus 1, you know, this is equal to, yes, this one is sin t. Okay. And therefore, yes, therefore, Laplace inverse, here is s cube, and you operating here the integral formula for the Laplace inverse. Okay. So 1 by s and s square plus 1, yes, this is equal to 0 to t, yes, sin u du, and this is again is equal to minus of cos u, that is if you taking the limit minus of cos u, yes, and taking the limit from 0 to t, that is this is equal to, you get 1 minus cos t. Here you using integral property. Yes, I think you know this integral property, that is 1 by s f of s is equal to this one. Then you can substitute this inverse property, and that is here we have defined this one. Short form we have defined this. If Laplace inverse fs, this is equal to ft, yes, if this one is equal to ft, then yes, Laplace inverse, yes, then Laplace inverse, yes, integral from s to infinity f of u du is equal to, yes, du is equal to, this is equal to ft by t. You know this property? Yes. So we operating here the integral property, and therefore this one. First by 1 by 1. Now, because in this question here is s cube, yes, here is s cube, so you operating next time again. Okay. Yes, in the next time. Okay. So now another one is, because here is in the question here is s cube, so again operating 1 by s and again operating in 1 by s, then you get the result. Yes. Okay, clear? Yes. Now, so Laplace inverse, yes, Laplace inverse 1 by s square, next time s square plus 1, yes, this become again operating, yes, 0 to t, yes, 1 minus cos u, yes, du. Yes, clear? Because first you have to find out this one. Here is 1 minus cos t in first operating, yes, so here is also operating, this one is 1 minus cos t, yes, and integrating this, you get u minus sine u. Yes, clear? And now taking the limits from 0 to t, that is equal to t, yes, t minus sine t. Yes, clear? And now again Laplace inverse 1 by s cube s square plus 1. Your question is this one. So again operating 0 to t, yes, and here is f of, in terms of f of u, that is u minus sine u du. Yes, and this become, this is equal to u square by 2 plus cos u, and operating the limit from 0 to t, you get the result. Here is equal to u square, that is t square by 2 plus cos t and 0, then cos 0 is 1, that is this one is minus 1. Yes, clear? Yes, okay. Okay, next video I have defined some other questions. Yes, okay, thank you.